path product. Here we are learning about path product rules. So associative for multiplication, we are following 16 different rules. So first rule number one is here. A of BC, which is equals to AB of C, which is also equals to ABC, where A, B, C are path names and set of path names are path expression. So these are our path names, and set of this kind of path names are considered as a path expression. Here path whose length is 0 is denoted by number 1. So here if you are considering two nodes, in between we are specifying a path. Okay, so if we are considering a single node which does not have any path, then it is denoted with a to the power of 0, which is nothing but it's a 1. And also in subpath also we can represent with x to the power of 0, which is also 1. Next, path sum. Plus sign is denoted path names where part of the set of paths. So here path sum is denotes path in parallel between two nodes. If you are considering two nodes, in between there are two different paths in the same direction. Okay, so here link 1 and link 2 both are in the same direction. So these links are nothing but they are in the parallel links between two nodes. So which is denoted with plus sign. To adding these particular path, we can write an expression. So if x and y are the set of paths lie between the same pair of nodes, such as x and y. Here name of pairs known first express denoted the union of those set of paths. Here next example, let's consider this particular flow graph. Here first link which is having weight f and other link up in the same direction x, y, t and g. Next these are the parallel links which are going. So without we have specifying any nodes in between these paths. So here first set of parallel paths denoted by x plus y plus t. So this is one set. So here you can see this is a one set. So which is denoted with x plus y plus d, because they are in a parallel direction, same direction they are going. So x plus y plus d. Next second set of parallel paths denoted by. So this is a second set of parallel paths. Here is a second set. So this is first set 1, and this is second set 2. So this parallel path can represent with u plus v plus w plus h plus I plus j. So we are adding these links. Next, set of all paths in flow graph. So this in flow graph, set of all paths. So whatever the path it is going. So first set we have S1 and second set S2. So f of S1, g of S2, k. So we can represent with f of x plus y plus d of g of u plus v plus w plus h plus I plus j of k. In this way we can represent an expression. So uppercase letters represented individual segment names. So here uppercase letters are specifying individual segment. So they are separate segment. Okay, so that is PQRS. So these are our different links. So set of links are represented with the capital X. So here in between there may be any number of set of links. It should be there, but we can imagine if there is a number of set of uh, links in a particular path, we can represent with capital X. So wherever we are using the capital letters, it is nothing but these are our segments. Okay, so because the path sum is a set of union operations. So path sum we are specifying a union operation. Next one, rule 2. So it is a commutative law. X plus y, which is equals to y plus x. Rule 3 is x plus y of plus z is equals to x plus y plus z, which is nothing but x plus y plus z. So this is an associative law. So distributive law. So for going to distributive law, the product and the sum operations are distributed. So product and sum operations are distributed here. Okay, so are distributed and rules of multiplication is applied. So rules of here we are applying multiplication. So this rule 4 is representing the distributed law. So A of B plus C, AB plus AC, and B plus C of D is equals to BC plus BD. Next, applying these rules to a diagram. So this diagram we are applying the rules, the above rules. Okay, here first one we have 5 different nodes, and in between they are having links. Here we already imagine that if they are both the links are in a parallel same direction, both the links are going in a same direction, we can add this particular parallel links. So here we can specify this particular set we can represent with A plus B. Okay, and the second set here in between this second set we can represent with C plus D. Okay, so in this way E of A plus B, C plus D of F. Again we are simplifying this particular expression. We can get E of AC AD, so AC plus AD plus BC plus BD of F. Once more, if we are simplifying it, we can get the sum of products of expression. So EACF plus EABF plus EBCF plus EBDF. Let's go for absorption rule. If x and y denotes the same set of paths, then the union of this set is unchanged. Here, if we are considering the x plus x, in absorption law, we will get x itself. So if we are parallel links, if we are both are in the parallel link, the set of parallel link we need to add. Loops. Loops can be understood as an infinite set of parallel paths. If a loop which is having an infinite number of parallel paths, say that the loop consists of a single link B. So here each in between two nodes they are collection of links it is going. So a single link we can represent with B. B to the power of 0 also. So then the set of all paths through that path loop point is B0, B1, B2, B3, so on, Bn. So this potentially infinite sum is denoted by P of B star. So if here if you are considering these are the finite number of links because we are representing with B to the power of n. If there are unlimited, infinite number of links, we can represent with B star for an individual link and by X star. So here you can look this example where we can represent with infinity number of loops. The path expression denoted by above figure, we can specify A, B star, C, because this loop cannot exit from uh, second node. Okay, so from second node it is repeating, okay, number of time it is repeating and it is not ending in a particular place. It is not ending, so that's why we can call it as a B star. So here A, B star, C, which is equals to AC, ABC, ABBC, so like that we can represent. Then A star we can specify with A star A, which is also nothing but A to the power of plus. Okay, so in this way we can represent. So here if we have a node A, so here let's consider this example. Okay, so if we have one node, okay, and having one link weight is A. Second node which is repeating itself, means it is having a loop, never ending loop. So here we can specify A and A star. Here we will multiply A with A star, or else we can again this one we can also write A star A. So this expression we can simply represent with A to the power of plus. Okay, so like that, same segments also we can apply same expression. It is more convenient to denote the fact that a loop cannot be taken more than a certain, say, n number of times. A bar is used under the exponent. So here you can represent a bar under the exponent to denote the uh, fact as follows. So here x to the power of n with below the bar is equals to x to the power of 0 plus x to the power of 1 plus so on up to x to the power of n. Next, rule number 6. Here if you are considering a finite number of paths, so x to the power of n, and this is an x to the power of m bar, which is a set of paths. So if we are adding this one, if x is n is greater than m, then we can represent x to the power of n. Here m is greater than n, we can represent with x to the power m. So here x to the power of n, x to the power of m, we can product this one with n plus m. Below we can represent bar. Next one, next rule, x to the power of n, x to the power of star is equals to x to the power of star, x to the power of n, which is equals to x star. Next rule 9, x to the power of n, x plus is equals to x plus x to the power of n, which is also nothing but x plus we can represent. Here rule number 10, x to the power of star, x plus, which is equals to x plus x star. You can also represent with x plus. Here rule 11, 1 plus 1 we can represent, which is equal nothing but 1. If rule 12, 1 x which is equals to x1 which is equals to 1. Next one, the following proceedings are set of paths by a path of 0 length denote does not change the set. So rule 13, 1 to the power of n is equals to 1 to the power of n is equals to 1 star equal to 1. So all of these are the same thing. If we are applying 1 with a set of 1s is nothing but is equals to 1 only. Okay, so no matter how often you are traveling a path of 0 length, So 0 length, how many times you are following, you will get 1 only. So the path is a path of 0 length. So path is path of 0. So path of 0 is nothing but a to the power of 0, which is equals to 1. So 1 plus is 1 star, which is nothing but is equals to 1. So this is a rule 14. The null set of paths is denoted by the numerical 0. It obvious the following rules. Rule 15, x plus 0 is equals to 0 plus x, which is equals to x. Rule number 16, 0x equal to x0, which is equal to 0.